Guys, my name is Raju and today I'm going to talk about one of the another easy problem which is Piot index, or we can also say that find out the equilibrium point. Let's try to understand the problem statement. What does it means by Piot index or equilibrium point? So I've been given an array, integer array nums. Calculate the Piot index of this array, right? What does it means by that? The Piot index where the sum of all the numbers strictly to the left of that index is equal to the sum of all the numbers strictly to the right index, right? So that is what the meaning of Piot index. For an example, we have given input example 1 2 3. Let's try to understand this from here. Let's understand what is actually mean by equilibrium point or Piot index and how we are kind of trying to understand this particular portion. So let's look at that example. So for an example, if we'll just talk about the Piot element, right, or maybe equilibrium point, if we'll see that the array is given to me is 1 7 3 6 5 6, right? So let's try to do one thing. Let's try to index these numbers. So I'm saying that this is 0 1 2 3 4 5. These are the index. If we'll try to, let's suppose if someone is uh, standing at index number 3, which is nothing but this one, right? If we'll just accept this part, if we'll try to add this part, right, and also if we'll try to add this part, let's add it. So let's suppose if I'm saying that if someone is standing at 6, there is a person who is actually standing on 6, and what I'm saying that 1 plus 7 plus 3, right, it is actually becoming 11, right? And if we calculate the right side, so 5 plus 6, which is nothing but 11. So means left side also and right side also both are same, then in that case we are saying that point as equilibrium point. Let's suppose if I'm taking this example again, 1 7, let me take a color here, 1 7 and 3 6 5 6. Can we say that 0 1 2 3 4 5? Can we say this is a equilibrium point? No, because if you see that left side we don't have. So I'll say that there is a left sum. Let's suppose there is a variable which is 0, and if we're standing here, right, so we'll not include this. Instead I'll try to include from here to here. If we'll add it 1, sorry, this is 7, right? So if we'll just try to add 7 plus 3 plus 6 plus 5 plus 6, right, if we'll add, this will become 10 and this will become 11. So 21 plus 6, 27, right? So it is going to be 27, and 27 which is coming at the R sum side, right? This is something like R sum. So 0 and 27 cannot be equal. Is it equal? No, it's not equal. So if this is not equal, this condition is not met. In that case, we cannot say that this particular point, what I'm trying to highlight it here, this particular point cannot be equilibrium point. We can check for this one, and left side if you look at that there is a 1, and right side will try to add up all this. Similarly, for standing here, we'll check all the left side and we'll try to add all the right side. If we're standing here, we'll look at that all the left side and everything is the right side, right? So this is the point where we are saying that it's nothing but equilibrium point, because if someone is standing at this particular location, right, if I'll just try to look at all the numbers which is in left side, 1 plus 7 plus 3, and all the number which is right side, which is nothing but 5 plus 6, right? So this is 5 plus 6. So if we'll just try to add it, we can say that this is 11 and this is 11, both are equal. So this particular point is 6, which is nothing but the equilibrium point. Now let's look at that another example. If let's suppose if someone is standing here, so left side will be 0, right side will be 5, which is not equal, right? Not equal. So this is will not be considered. If someone is standing here, so we'll say that all the things in the left side is 1 and 3, which is not equal. So this is also not an equilibrium point. Index numbers, this part, and if we'll just go to the last index, right, if we'll just try to add up 1 plus 2, which is nothing but 3, right, and right side is also 3. Right side is 0 basically, not 3, because you are standing here, so we will not include it. So right side is 0, so this is also not equal, this is not considered equilibrium point. So in that case I am going to return -1. If there is no equilibrium point, we'll have to return -1, right? And if you look at this example, 2 1 -1, just try to quickly understand it. 2 1 -1, we're trying to take an index, so index is nothing but 0 1 2. If someone is standing here, so left part is 0, right, and right part will be 1 plus -1, which is nothing but 0. So we can say that at 0 index is nothing but the equilibrium point, or we can say that this is Piot index. So here is the answer which we got it here, right? Because this part is 0 and left part is already 0. So 0 equal to 0, which is nothing but a Piot element or equilibrium point. I hope the problem statement is clear to everyone, right? Let's talk about how we can solve this problem. And this is a famous and easy problem. So here we have a solution for it. If we'll try to understand this problem, right, let's look at that, how we are actually going to solve this particular problem, right? Okay, we have to take this one, right? So see that the thing is written here. We have a Piot index where input is given nums, right? What we are trying to do, we are trying to take left sum and right sum, right? So that we'll be able to calculate left sum and right sum, and we'll keep comparing it. So what we are doing that, first of all, we are trying to fill everything in the left sum part. If you see that all the element we are trying to add up, right, and we are trying to sum it. So we have all the numbers calculated for the left sum part. Means whatever array is given to you, that all the numbers from the array we are going to add up. And we'll do dry run one more time, so no worries about it. So we have all the summation, right, all the elements is actually been summed up, and we have stored the result in R sum. What we're trying to do here, we are trying to start with a loop where we are just trying to write the logic. So how the logic, what logic we are trying to say that, we are trying to say that if left sum is equal to R sum minus nums at I. Why we are saying that, why we are not saying R sum, just left sum equal to R sum? Reason being, because we have to actually exclude the current element. And if you look at that, in this particular portion, we are trying to kind of exclude the current element, which is nothing but this one, nums at I. We have to do that. And if it is equal, then in that case only we are going to say that yes, return the result, right? Return the result. So in this scenario, we are trying to return the result, which is nothing but I. If not, we are trying to add up that current number to the left sum part, and we are trying to do a subtraction from the right sum part, right? That's what we are currently doing it here. And if it is not found, if there is no any scenario matched, then in that case we are going to return -1. That is how we are actually going to solve the problem. Let's try to look at a simple test case. Like, let's suppose I'm trying to take the test case called first one. So let me take that test case and we'll do dry run, and we'll try to understand this problem statement, how we are actually going to solve it. Very quick. Yeah, so the element number is actually nothing but, we have 1 7 3 6 5 6, and we are just going to index it with 0 1 2 3 4 5, right? What we are doing, first of all, we are just going to calculate the left sum. So I'm just talking about this particular portion, right? So we are trying to calculate the left sum. So what will be the value of left sum? Let's try to add up all the elements, right? Because as of now, if you see that left sum is nothing but 0. So we are saying that 0 plus first element, then second element. So basically we are going to say 0 plus 7 plus 0 plus 1 plus it's 1 plus 7 plus 3, right, plus 6 plus 5 plus 6. Let's add it. So it's a 7 plus 1, 7 plus 3 is 10, plus is 11, 11 plus against 11 plus 6. It's actually nothing but 22 plus 6. 22 plus 6 is nothing but 28, right? Alright, so now we have 28. Now what we are trying to do, this particular portion is actually been completed. This particular portion is actually been completed. Now we are starting from here. So we are checking if, right, left sum means we are saying 28 is equal to R sum. What is the value of R sum? R sum is nothing but we are saying 0, right? So I am saying that 0 minus, okay, sorry, this is actually left sum because we don't want to keep it negative part. So this I am saying that this is something like R sum because I wanted to decrease it from that R sum, right? So if R sum is actually having that all the added value, then only we can try to say R sum minus num set I, right? And left sum is already 0. So yeah, let me just do it here, make sure that how it is getting calculated, right? So what we are trying to do, that first of all, if you look at that in the given example, right, we are trying to calculate nothing but R sum. So we have result of R sum, not left sum. Left sum is already 0. Anyone we can do that, but we are just trying to calculate everything from R sum. Since we are moving from this direction to this direction, we can also even though do addition in left sum also, but we have to come from the right side, right? Then this logic will not work. We have to take an index opposite. I mean, not I currently we are starting 0, right? We have to start from length minus 1 in that case. Since we have just completed R sum, then we have to actually move from the left side. To move from left side, we are actually moving from left to move from left side, we are trying to move from index number 0, from this index. Then we are trying to move from this index to again this index, then this index, then this index, then this index, then this, right? So that's the reason we are trying to start from index number 0, and that's what we are doing that. So there is another possibility also we can do, but let's start from index number 0, right? So what we are trying to do, that we are saying that left sum, what is the left sum right now? Left sum is currently 0. So let me write it. Left sum is as of now is 0, right? So I'm saying that if whether 0 is equal to R sum, which is nothing but 28 minus num set I. Num set I means 1, right? Because we are talking about index number 0, which is actually equivalent to 0 is equal to 27, which is not. So this is not a equilibrium point. So here for index I equal to 0, we are able to see that this is not equilibrium point. Let's talk about index number I equal to 1. If we're talking about I equal to 1, I equal to 1 means, okay, yeah, so this is not the equilibrium point. In that case, we are trying to update it. Left sum, which is left sum will have some change. So left sum we are trying to add the current number. So we are trying to add the number in the left sum, which is nothing but 1, and we are trying to do minus 1 here, right? Because we are trying to say that left sum equal to left sum plus num set I. So whatever left sum was there before, which was 0, we're trying to add up. So finally we are going to get 1, and finally we are going to get here nothing but 27, right? It will keep updating it. Now we are trying to say that for index number 1, what you are doing there? We are saying that is 1 is equal to what? 27 minus current element index value. What is that? 7, right? We are talking about index number 1. What is that? 7. Finally we are saying that, if you say that, finally what you are saying that, is it 1? I can say that is nothing but equivalent to, is it 1 equal to 20, right? Which is actually not. If not, what we are trying to do, that we are trying to say that left sum to be added the current number. And what is the current number? Which is nothing but 7, right? So I am saying that 1 plus 7, which is nothing but 8. What is 1 plus 7? Here I'll just do that. It's 8. And from here, we are trying to say that minus 7, which is nothing but 20. So finally we have left sum and right sum, right? Alright, let's move to the index number 2. So let me try to quickly remove this part. We don't need it. And we are trying to move to I is equal to 2, right? If we talk about I is equal to 2, so we'll try to compare. We'll say that left sum. What is the value of left sum? Which is 8. Whether 8 is equal to what? Right sum, which is nothing but 20 minus current value, a value of the current index. So we are actually standing at I equal to 2, and I equal to 2 is nothing but this part, right? This is I equal to 2 minus 3 we are doing. So what we are trying to get it? We are saying that whether 8 is equal to 17. No, it's not. So this is also not a point element or maybe equilibrium point. Anything else we can call. If not, we are trying to update the left sum, right? So we're trying to add the current element. So we are saying that 8 plus 3. So finally we are going to add plus 3 here and minus 3 here. So if I'm saying that, it is going to be happen 11, right? And what is happening here? 20 minus 3. 20 minus 3, right? What is that? 20 minus 3 is nothing but 17. That's what. Now what we'll do? We'll try to check. We are just moving to index number 3. For index number 3, what we are doing? We're checking whether left sum. Left sum is what? 11. Whether 11 is equal to what? Right sum. What is current right sum? Which is nothing but 17 minus nums at I. Nums at I means nums at 3. And what is the value app? Nums at 3. This is the one. I'm saying that 6. So I'm saying that whether 11 is equal to 11, right? That's what we were saying. Yes, it is. If it is, then we are going to return this particular index I, right? So I'm saying that I equal to 3 means index number 3 is a point element. That's what we were trying to say here. That is overall dry run, and that's how we are trying to understand this actually solution for this problem in the optimal way. If we'll talk about the time complexity for this problem will be order of n, and there is no space which we are currently using it. So space will be order of 1. Now let's try to understand that how we are writing the code to basically submit on Leetcode. Let's look at the code part, right? So this was the problem statement which I have explained it. Now let me try to talk about the coding part. So if you look at that, I have already submitted. I'm trying to retrieve that what I have submitted it. So here I'm just doing the same thing whatever we have discussed. We have left sum equal to 0, right sum equal to 0, right, at line number 3. Now we are moving to line number 4. We are trying to get all the summation of all the element basically, and we are trying to store the result in the right sum. Once you've done that, we are trying to use another for loop, right? So so we are trying to say that left sum is equal to r sum minus nums at I. We are not comparing left sum and right sum, right? We are just comparing left sum is equal to r sum minus nums at I, because we are actually standing at nums at I position. So we are not going to include that, right? And we are excluding it. If it is, then we are saying yes, return that index. If not, then we are moving it further. We are saying that L sum equal to nothing but L sum plus nums at I, and R sum equal to R sum minus nums at I. And here is, as we talked about that, overall complexity is order of n. Since we are having two for loop, because one for loop is we both are in parallel. It's not one for loop inside another for loop. So we are just calculating it, all the result from line number 4 to 6, right? And we are just getting that order of n. And also for the loop which is starting from line number 7 to line number 13, that is also order of n. So basically we can say that order of 2n, which is 2 order of n. Basically this is 2 can be ignored because this is something like constant. So if we'll talk about overall complexity, which is nothing but order of n, right? And if it is not matching, if there is no equilibrium point found, in that case we are trying to return the result at line number 14, which is nothing but -1, right? So let's try to run this. If we'll run it, we can look at that all the test cases is actually getting passed, right? And test case number 1, right? Test case number 2, 1 2 3, it's -1 -1. For test case number 3, it's 0 and 0, the one which we had discussed in the starting, right? Let's try to submit the problem, and this should get submitted. And here we go. We have around 746 test cases if you look at that, and all the test cases is been executed and it's been passed. If you look at the runtime, it's just 1 millisecond, and it's really like it's having a 2 optimized solutions to basically just in a 1 millisecond and a lower time complexity basically to get this result. Thank you guys for watching. Kindly leave any comment which will actually motivate me to solve the problem. Let me know if you wanted to discuss on any of the problem from array or any of the data structure to make the video and to understand more on this. Thank you for watching. Thank you. Have a good day. Bye.